Company plans to build a new fairground ride. The ride consists of a capsule that will hold the passengers, and the capsule will be attached to a tall tower. Capsule is to be released from rest from a point halfway up the tower, and then it's going to oscillate in a vertical line, up and down. The vertical displacement x at the top of the capsule below its initial position at time t seconds is then modeled by this second order differential equation, where m is the mass of the capsule, including its passengers, in thousands of kilograms. The maximum permissible weight for the capsule, including the passengers, is 30,000 newtons. Using g equals 10, and assuming the capsule is at its maximum permissible weight, explain why the value of m is 3. So max weight equals 30,000 newtons. Therefore, the max mass is going to equal 3,000 kilograms. I'm just dividing through by gravity here, because weight equals mg. And then m is in thousands of kilograms. So m equals 3. That's what we need to do here. Show that a particular solution to the differential equation is given by this. Okay, well, there's two approaches here. You could try and derive a solution. You could let x equal a sine t plus b sine t. And that's what you'd have to do if we weren't sort of given it. But because it's a show that, it's just going to be easier to sub in the result that we have. So I'm going to go with that. And we don't have to work out a and b. Okay, so let x equal 40 sine t minus 20 cos t. Just got to differentiate it and then differentiate it again now. Okay, so, and then remember m is 3, so therefore minus 120 sine t plus 60 cos t, that's just me putting that in, then plus 160 cos t plus 80 sine t plus 40 sine t minus 20 cos t. Maybe I should just say this is the left-hand side. That is going to equal, if we sort out the signs, we've got minus, actually they all cancel. There's no sine t's. And then here I get 220 cos t minus 20 cos t. I get 200 cos t. And this is the right-hand side. So result follows. And x equals 40 sine t minus 20 sine t is a particular solution. Normally I call this a particular integral, but it's okay. Hence, find the general solution of the differential equation. So we've already dealt with like x that gives us the right-hand side. Now we're going to set it equal to 0. And we're going to let x equal a e to the kt as our trial function. Then x dash becomes kx, x double dash becomes k squared x. So when we sub it in, remember this is a 3, we get 3 k squared x plus 4 kx plus x equals 0. We divide through by x, we get our auxiliary equation. You can go straight to this. I'm just trying to remind you where it comes from. And let's solve it. Actually, I think it factorizes. You can put it in your calculator alternatively, so it's just, but this one's quite nice. So k equals minus a third or minus 1. And that means that x CF, that's our complementary function, is going to equal a e to the minus 1/3 t plus b e to the minus t. And then the general solution are the two added together. The particular integral, they call it the particular solution up there. Yeah, it's not the particular solution because that's when you put in your boundary conditions as well. So I'm just going to change it is a particular integral. But ultimately, we're going to get a e to the minus 1/3 t plus b e to the minus t, then plus that 40 sine t minus 20 cos t. Okay, one bit to go. Using the model, find the nearest meter, the vertical distance at the top of the capsule from its initial position 9 seconds after it's released. There's actually quite a bit to do here because we need to work out A and B first. Now we're told right at the beginning that, where is it? The capsule is released from rest from a point halfway up the tower and then made to oscillate. So because we're interested in its vertical distance from its initial position, we can say that when t is 0, x is 0. It doesn't matter it's halfway up, we're relating it to its initial position. And then because it's released from rest, dx by dt is also equal to 0. And we can sub in. So if we just sub into our general solution, we'll get 0 equals a plus b minus 20. So a plus b is going to equal 20. Now we can't avoid it, we're going to have to differentiate, but it's not too bad. It's not like sometimes you get like e to the t and sine in there as well, and you have to use the product rule. Not too bad here. We're just going to get minus a third a e to the minus a third t minus b e to the minus t. We've already differentiated these once. Okay, so then 0 is going to equal minus a third a minus b plus 40. So a third, wait, actually, this is perfect. I can just, I can write it as minus a third a minus b equals minus 40, and then take this and add them together because the b's are just going to cancel. You could rearrange it and subtract them, but it's easier to add, I think. So 2/3 a is going to equal minus 20 times by 3 divide by 2. A is going to equal minus 30. Then b is going to equal 50 because the two sum together to give 20, and we're so close now. So x particular solution, we put it in, we're going to get 50 e to the minus t minus 30 e to the minus a third t, then plus 40 sine t minus 20 cos t. So when t equals 9, just put this in your calculator. X then equals 33. Make sure you're working in radians, 33.219. So the nearest meter, 33 meters. Nice question, well done.